Hi, this is Brian Caffo, and welcome back to my YouTube channel. It's been a while since I posted. I'm going to try and do something now where I talk about things people post on Twitter, but I talk about them on YouTube, ironically. Um, so I wanted to talk about one of the most fascinating discussions that's happening in the field of statistics, and that is this discussion primarily between two really top researchers in the area, Hernan and Pearl, talking about causality and the role that manipulatable factors play in discussing causality. It's a fascinating discussion. And so the first place I would suggest you would start is to look at this paper by Hernan and Taubman that's titled "Does Obesity Shorten Life? The Importance of Well-Defined Interventions to Answer Causal Questions." It's in the journal Obesity. It's really a fascinating read, and I think it really kicked off this assumption. And these are all really fantastic researchers in this area. So if you get a chance, also follow the Twitter thread. I'll put some links in the video description below. First of all, it's nice Twitter too. Like, it's a really academic discussion, which is fantastic. So in this paper, they discuss and I think they use this example because there was historically one of the first examples of a randomized trial was from the Bible, and a king talking about a trial to reduce obesity or increase life. So they talk about a king who wants to increase lifespan in his kingdom. And so he talks to, here's my king I drew, and he talks to the royal statistician about how to do that. And they talk about two different kinds of intervention: an exercise intervention and a diet intervention. And they get different, and an exercise plus diet intervention, and they get different answers. And so the king is really wondering then, well, is it true then that reducing obesity can increase the lifespan for my subjects? And the statisticians are saying, well, that's not an answerable question because obesity isn't directly manipulable. What is manipulable is the policy that we enact, whether it's a dietary intervention, a exercise intervention, or both. And they say, well, we can answer among those three things. We know that the doing both seems to do the best. So I would describe this kind of analysis as sort of policy causal analysis. So typically in this style of causal analysis, you define cause via counterfactuals. So a cause is the difference, or let's say, between the lifespan of a person had they received the intervention versus had they not received the intervention. But of course, we can't have a person both receive and not receive the intervention. So what you can estimate are marginal quantities, like the average difference among the treated, average difference in the counterfactuals averaged over the population. That's called the average treatment effect. But you can really estimate pretty much any marginal quantity where the marginal distribution of the treated, of everyone having been treated, and compare that to the marginal distribution of everyone not having been treated or having received a different treatment. Okay, so any difference in those marginal distributions is up for gain. And another important aspect of this style analysis that often doesn't get discussed as much as I think it should be is that your definition of cause depends on the sample. And this makes total sense for policy type questions. You would expect a different treatment effect if a significant fraction of the king's subjects were malnourished than if a significant fraction of the king's subjects were actually obese. So an exercise intervention among malnourished people would shorten life, whereas an exercise or dietary intervention among people, obese subjects, would actually lengthen life. So the definition depends on the sample. The definition of the average cause that you're looking at depends on the sample. A big focus in this area is also on robustness, with good reason too. People don't want to make a lot of assumptions about mechanisms and models and what have you. They don't want to understand what are the explicit mechanisms that go into the dietary intervention increasing the lifespan. Instead, they think about, if I apply this intervention, let's investigate it without having to factor in a lot of other considerations and modeling considerations. We want our causal estimates to be as robust as possible. So there's a huge emphasis on robustness in this area in many aspects. But the downside of this is, of course, you can't investigate non-manipulatable factors. That was their whole point. So, example, things like sex and race, you can't really talk about them as being causative factors. Now, or if you do, you have to think, in terms of weird, somewhat weird things like sex or race being randomized at the, before birth, in which case it gets aliased with all the things up to the point that you're investigating sex or race. So so in other words, it's difficult to talk about a localized definition of sex or race as having a factor, having a cause. And then they all make heavy use of the idea or the actual implementation of randomization. In the example that they gave in the paper, they were talking about an actual randomized trial, but then a lot of the methods that get developed in this area kind of think back towards the idea of randomization, using it as a model. I would say the opposing discussion is really looking at mechanistic causal analysis, and usually through things like directed acyclic graphs. So the graphs in these directed acyclic graphs, the graphs encode probabilistic relationships and the arrows encode causal relationships. And a good way to think about this is these types of models, to me, seem to make the most sense if you're thinking about something that you can kind of reduce to thinking like a circuit. So imagine if the king, instead of wanting to decide whether or not he should enact a policy of a dietary or exercise intervention, but noticed that the neighboring kingdom had electric lights and wanted to understand how or why the electric lights worked. So here's the king saying, wow, because the neighboring community has electric lights. So this kind of mechanistic causal analysis is the first thing that it requires is you actually have to postulate these directed acyclic graphs. So I kind of wrote one down here that I might have thought of for the wiring, is that you have the electricity coming into the switch, you have the switch goes to the wiring goes to the bulb, and the bulb may or may not be functioning. And if everything's going good, then you have light. So in order to execute this kind of analysis, both the plus and the minus of it is you have to postulate causal mechanisms and then evaluate them with respect to the data. And sometimes the data can adjudicate between causal mechanisms and sometimes it can't. But there is a great benefit, and I think this is what many of the practitioners of this style of analysis would tell you, is that there is a great benefit to just postulating causal mechanisms, that you receive a scientific benefit from actually just writing them down before you even take one step towards analysis. So that is a plus and a minus. And then it defines cause via the diagram and potentially hypothetical interventions or states of nature. So it allows you to be a lot more flexible in how you define the word cause. And Pearl has this great book out now, which I would highly recommend, called The Book of Why. And he actually covers this quite clearly in the book, where he talks about the sort of loaded nature of the term cause. So if you take a step back from the word cause and just think, what I'm trying to investigate is this global sense of mechanisms, then this style of analysis gets at what we often internally think of when we mean cause, even though that doesn't have a great, robust, formal definition. It's hard to think of how you could intervene to change someone's gender or how you could intervene to change someone's race. But nonetheless, it is easy to think about hypothetical mechanisms by which gender would be a node in the mechanism or race would be a node in the mechanisms. And I like to think of circuits as a model. So this style of analysis plays very well for me when I'm thinking about some basic neuroscience, which is an area that I tend to work in often, especially because we're often using a circuit as a direct or actual model of the brain. Of course, these two theories bleed into one another. As an example, these kinds of mechanistic models, these directed acyclic graphs, they imply the counterfactual relationships. The mechanistic model would imply exactly what the counterfactuals are, because it builds up a complete model of the world insofar as you're interested in that particular resolution. Of course, this requires assumption. It requires the things that many of the people who think in terms of counterfactuals and that style of analysis aren't interested in making. And I would also say, I'm distinguishing between mechanistic understanding and policy style understanding causes. But this kind of policy style causal analysis is very useful for studying mechanisms. If you wanted to study the light switches for the king, well, one of the first things you might do is go randomize flipping the light switches, and that would give you a pretty good sense because you've isolated everything else. You've tried to control everything else to keep it as constant as possible, and you flip some light switches, or you randomly switch some light switches, or you randomly cut some wires and see what happens. At any rate, this kind of randomized trial is useful in mechanistic analysis as well. And you see that, of course, when people who are studying mechanisms of various sorts implement randomization, maybe controlling for other factors or holding as many other factors as they can constant. So some other things to consider about are, how useful are mechanistic models when you're trying to study transient phenomena. So as an example, if you're studying the stock market, if you find out any significant rule about how stocks behave, then the theories of efficient markets say that those rules are then going to get encoded into the price and become useless. So how much effort do you really want to put into understanding mechanisms when the mechanisms are going to be constantly changing? The same thing could be said of things like ad campaigns. People's attitudes change so that what is effective today may not be effective tomorrow. So it may not even make sense to devote a lot of energy to discovering mechanisms. And then I erase some stuff. And then I think it's a very interesting discussion in all these problems to talk about what is actually being modeled as random. And in Pearl's work, I really quite like, he has a very deterministic view of statistical modeling. So he talks about, probability really just being an aggregate of things we don't understand, components of the causal mechanism aggregated together and treated as if random. So a really kind of deterministic way of thinking, where it's often a little less clear, I think, in these policy causal types analyses. Different kinds of randomness bleed together, and it's often a little hard, for me at least, to nail down exactly what is the randomness that we're studying. So at any rate, that's just some thoughts on this stuff. Some further reading, I would definitely read that obesity paper. It's really easy to read. It's fantastically written. It's very thoughtful. And then Pearl's reply is also same thing. And then I just recently bought the Book of Why, and I thought, which is Pearl's kind of popular science book about his the collective work on causality, but primarily focusing on this sort of mechanistic DAGS style of analysis. It's quite good. And I especially like that it covered a lot of the history of statistics, among other things. So hopefully I'll start having videos more often. And thank you for tuning in. If you get a chance, subscribe and leave some comments.